Hello everyone, and welcome to today's presentation. I'm excited to share with you the 30 most asked telecommunications competency-based interview questions with answers. In this session, we'll explore common interview questions in the telecom field, along with effective responses and strategies. We'll cover a range of topics, from resolving complex technical issues and collaborating across departments, to staying current with industry trends, troubleshooting remotely, managing challenging projects, and prioritizing tasks in fast-paced environments. Let's get started and dive into these essential questions that can help you succeed in your telecommunications career. In my previous role, I faced situations where multiple critical issues would happen at the same time, like network outages and equipment failures. It was important to assess each problem's impact carefully, then prioritize based on how severe it was and how much it affected customers. I allocated resources accordingly, which allowed us to focus on the most urgent issues first while still managing the overall workload effectively. This approach helped us respond quickly and efficiently to complex, high-pressure situations. Ensuring that our documentation remains accurate and accessible to all stakeholders is essential for smooth operations and effective knowledge transfer. When everyone has clear, reliable information, we can work more efficiently and reduce misunderstandings. This transparency helps new team members get up to speed quickly and keeps existing team members aligned on goals and procedures. It's about creating a shared resource that everyone can trust and refer to whenever needed, which ultimately supports seamless collaboration and continuous improvement across the organization. Vendor relationships built on mutual trust and collaboration are essential for achieving successful project outcomes. When we work closely together, sharing ideas and supporting each other, we create a strong foundation that helps us overcome challenges and deliver the best results. Now, let me share a bit about how I adapt to new telecommunications technologies or protocols. In this rapidly changing industry, I often encounter new systems and standards. For example, when we transitioned to IPv6 addressing, I took the initiative to learn on my own, attended training sessions, and collaborated with colleagues. By actively engaging in hands-on experimentation and continuous learning, I was able to understand the implications and best practices for implementation. This proactive approach allowed me to adapt quickly and seamlessly integrate new technologies into our existing infrastructure. Regarding ensuring high availability and reliability of our services, I focus on implementing redundant systems, like backup power supplies and multiple network paths, to eliminate single points of failure. I also rely on proactive monitoring tools, predictive maintenance, and rapid incident response procedures. These measures help us maintain continuous service, minimize downtime, and provide our customers with dependable telecommunications solutions they can trust. When I need to communicate technical information to non-technical stakeholders, I make sure to keep it simple and clear. For example, during a project kickoff meeting for migrating to a cloud-based telephony system, I used layman's terms and visual aids to explain the benefits and implications. Tailoring my message to the audience's level of understanding ensures everyone stays aligned and informed, which ultimately supports the success of the project. Customer satisfaction is always a top priority in my approach to telecommunications service delivery. I believe in responding promptly to inquiries and issues, actively seeking feedback to identify areas for improvement, and striving to go beyond expectations in service quality and reliability. Building strong relationships based on trust and responsiveness helps foster long-term loyalty and ensures our customers feel valued and supported. Finally, let's briefly talk about the OSI model. It's a conceptual framework that helps us understand how different parts of a telecommunication system work together. It has 7 layers, each with its specific function. The first, the physical layer, deals with the actual transmission of data, things like voltage levels, cable types, and connectors. This foundational layer ensures that data physically moves across the network. Understanding these layers helps us design, troubleshoot, and optimize our systems for better performance and reliability. Now, let's look at layer 2, the data link layer. This layer is responsible for node-to-node communication, meaning it manages data transfer between directly connected devices. It also handles error detection, which helps ensure data integrity, and flow control to prevent overwhelming the receiving device. Essentially, it makes sure that the data remains accurate and in order as it moves over the physical connection. Moving on to Layer 3, the network layer. This layer handles addressing, routing, and forwarding of data packets. It's the layer that establishes connections between devices on different networks, making sure data gets from the source to the destination across various network segments. Think of it as the layer that directs traffic on the internet. Next is Layer 4, the transport layer. Its main role is managing end-to-end communication between hosts. It ensures data is reliably transmitted from one device to another, handling error recovery and flow control. It also segments large data streams into manageable parts, so the transfer is efficient and reliable. Layer 5, the session layer, is all about establishing, managing, and terminating communication sessions between applications. It provides synchronization and dialogue control, which means it keeps the conversation organized and ensures that data exchanges happen smoothly between devices. Then we have Layer 6, the presentation layer. This layer translates data into a format that the application layer can understand. It deals with encryption, data compression, and data translation, making sure that data is readable and secure for the applications that need it. Finally, Layer 7, the application layer, is where network services are directly provided to user applications. This includes protocols like HTTP for web browsing, FTP for file transfer, SMTP for email, and DNS for resolving domain names. It's the closest layer to the user, enabling us to interact with network services seamlessly. Now, regarding the difference between TCP and UDP. TCP, or Transmission Control Protocol, is connection-oriented. That means it establishes a connection before data transfer begins, ensuring that data arrives reliably and in order. It checks for errors, manages flow control, and handles packet sequencing and acknowledgements. It's ideal for applications where accuracy is crucial, like web browsing or email. On the other hand, UDP, or User Datagram Protocol, is connectionless. It doesn't establish a formal connection before sending data, which makes it faster but less reliable. It doesn't guarantee delivery or order, which is acceptable for applications where speed is more important than perfect accuracy, like live video streaming or online gaming. Finally, how do we troubleshoot network connectivity issues? Well, a systematic approach is key. First, gather information. Understand what symptoms you're seeing, which devices are affected, and if any recent changes were made to the network. Then, perform basic checks like verifying physical connections, inspecting cables, and confirming device configurations. Use diagnostic tools such as ping to test connectivity, traceroute to identify where delays or failures occur, and network monitoring tools to get a broader view of the network's health. This organized process helps you pinpoint the problem efficiently and resolve it effectively. All right, now that we've identified the general issues, the next step is to isolate the specific problem. This means narrowing down the cause to a particular device, link, or configuration setting. By doing this, we can focus our troubleshooting efforts more effectively and avoid unnecessary changes. Once we've pinpointed the issue, we move on to resolving it. Common steps include restarting devices to refresh connections, reconfiguring settings to correct misconfigurations, or replacing faulty equipment if needed. These actions help restore normal network function quickly. Now, let's talk about quality of service, or QoS. This is a crucial concept because it allows a network to prioritize certain types of traffic. For example, we might prioritize voice calls or video streams over less critical data to ensure a consistent quality of service. It's all about managing bandwidth effectively. Implementing QoS involves several techniques. Traffic shaping, for instance, regulates the flow of data to make sure high-priority traffic gets enough bandwidth. Priority queuing ensures that important data moves to the front of the line for transmission. And resource reservation involves dedicating specific bandwidth or resources to critical applications, guaranteeing they perform well even during peak usage times. Understanding and applying CoS helps us maintain a reliable and efficient network, especially when supporting real-time services or sensitive applications. It's a key part of network management that ensures users experience minimal disruptions and high-quality performance. Certainly. Let me walk you through some real-world experiences that highlight how I handle complex interoperability issues, security, leadership, and task prioritization in telecommunications projects. In one particular situation, I was working in a complex telecommunications environment where I faced interoperability challenges between legacy systems and modern platforms during a system integration project. To resolve this, I conducted a detailed protocol analysis to understand the root causes of incompatibility. I identified specific configuration issues and then implemented protocol converters and gateways to enable seamless communication between the different systems. Collaborating closely with vendors was crucial. They provided insights and support. We also carried out rigorous testing to ensure everything worked smoothly, which ultimately led to a successful integration and restored system functionality. When it comes to balancing network security with performance, I believe it's all about adopting a layered approach. I implement strong security measures like firewalls, intrusion detection systems, and encryption protocols. At the same time, I optimize network configurations to ensure data flows efficiently. Continuous monitoring and threat intelligence play a vital role. They help me spot vulnerabilities early. Regular security audits ensure that security measures are up to date without sacrificing performance. It's about finding that right balance so the network remains both secure and fast. Leading a team through a major technology upgrade is no small feat. It requires meticulous planning and clear communication. I always start by explaining the benefits of the upgrade to the team to foster buy-in. Providing comprehensive training and support is key to helping everyone transition smoothly. We conduct extensive testing in controlled environments before going live, which helps us identify and fix issues proactively. Throughout the process, I maintain regular communication, gather feedback, and conduct post-implementation reviews. This approach helps minimize disruptions and ensures everyone is aligned, making the transition as seamless as possible. Finally, when managing tasks in a project with tight deadlines and limited resources, I focus on prioritization and smart resource allocation. I evaluate the project's goals, deadlines, and what resources are available. I often use project management methodologies like Agile or Kanban to break down work into manageable pieces. I prioritize tasks based on their strategic importance and impact on the customer. I also assign resources based on team members' skills and availability. Regularly reviewing progress allows me to adjust priorities if needed, keeping the project on track and ensuring deadlines are met without unnecessary stress. That's how I approach these challenges, by being strategic, collaborative, and adaptable to ensure success in complex telecommunications environments.